All right, so if I want to record, let's see here. So for my g of x, so if I want to do g of negative 2, then that's going to be negative f of negative 2 plus 3. So in other words, it's negative of that f of negative 2 is negative 19. And then I want to do plus 3. So that's positive 19 plus 3. If I do 19 plus 3, that gives me 22. Okay, and then if I want to do g of negative 1, it's going to be negative f of negative 1 plus 3. So what is f of negative 1? F of negative 1 is negative 3. So I'll have negative of negative 3 plus 3. So that's positive 3 plus 3, which is 6. Same thing. If I want to do negative of 1, that's negative 1 plus 3. Negative 1 plus 3 is positive 2. Negative of negative 1 is positive 1 plus 3 is 4. Negative of negative 3 is positive 3 plus 3 is 6. Okay, and then for my h, I have to be a little bit careful because I have that negative 1/2 inside there. So if I do h of negative 2, that's going to be f of negative 1/2 of negative 2. So that is f of positive 1. And I know f of positive 1 is negative 1. Okay, if I do h of negative 1, it's at f of negative 1/2 times negative 1. So that's f of positive 1/2, which is not a value that I have in my table. I don't have anything about 1/2. I just have 0 and 1. So this is an NA. For similar reasons, we're going to get NA when I do positive 1 as well. What about h of 0? That's f of negative 1/2 times 0, which is f of 0. And f of 0 I'm given as 1. And h of 2 is going to be f of negative 1/2 times 2, which is f of negative 1. And f of negative 1 is given as negative 3. So you can fill out the table there. Okay, for this one I want the period, midline, and amplitude. So let's start by looking at the kind of the bottom and top of the function. So it looks like the top is at 8 and the bottom is at 2. So halfway between 8 and 2 would be 5. So my midline is y equal 5. And my amplitude is how far it goes up and down from the midline. So from 5 I go up to 8 and I go down to 2. So my period then, my amplitude then is 3. What about the period? That has to do with if you look from tip to tip. So if I look from the peak to peak or valley to valley, I go from 0 to 2. So my period is 2 units until I complete a full cycle. Okay, for sine and cosine, I want to rank the following in order from largest to smallest. So again, the cosine deals with the x value. So if I think about these angles, first of all, we'll just draw a regular thing here. So cosine of 18 degrees, so 18 degrees is about here, 18 degrees. And if we look at the x coordinate associated with that, it's that. If I look at cosine of 12 degrees is slightly less than 18. And the x coordinate associated with that is going to be a little bit bigger. What about cosine of 155 degrees? So 155 degrees is going to be slightly less than 180. So it's over here. And so it has that x coordinate. And then 212, okay, so 212 minus 180 has a reference angle of 32. What about the 155? It has a reference angle of 25. Okay, so the 212 will be a little bit bigger in here, 212. And so its x coordinate is going to be a little bit closer to 0 than at 155, okay? And then I want to look at cosine of 95 degrees. So 95 degrees will be right here. And its x coordinate will be still negative, but closer to 0 there. And then what about cosine of 85 degrees? So that'll be right here, 85 degrees. And if I look at the x coordinate associated with that, it's like right there. So let's put these in order. So the smallest x value will be the one that's associated with the 155. So cosine of 155 is first. Then we have cosine of 212 is still negative, but a little closer to 0. Cosine of 95 degrees is still negative, but again closer to 0. Then cosine of 85 is the is the first one that's positive, right? But it's still pretty small. Cosine of 18 is a little bit bigger, and cosine of 12 is the biggest yet. So that's your order. Number 26, I want to find angles that have the same cosine as 230 degrees. So if I look at my angle 230 degrees, it'll be down here in the third quadrant, so I can draw that out. The cosine, again, is associated with the x-coordinate, so I want an angle that has the same x-coordinate, so it's going to be up here in the second quadrant. Let's look at the reference angle. So if I do 180 minus, 230 minus 180, I get 50 as my reference angle. So again, I want a reference angle of 50. So if this is 230, then this is going to be 180 minus 230. 180 minus 50, which is 30. 130. 180 minus 50 is 130. So those two angles will have the same cosine value because they have the same x-coordinate. So 130 degrees is the answer here. And if we want the same sine as 305, let's think about that. So 305 degrees is over here, and it has a certain sine coordinate. Sorry, I didn't really draw that very well. 305 will be more like so 305 will be more like over here somewhere. Anyway, so we want the y-coordinate of that to match. So we're going to be over here in the third quadrant. We'll have something like that. And we just want the reference angles to match up. So if we do 360 minus 305, I get the reference angle of 55 degrees here. So I need the same reference angle. So if I do 180 plus 55, I'll get a third quadrant angle, which is 235 degrees. And those two angles have the same y-coordinate, so they'll have the same sine value. Okay, on number 27, I'm looking at it's an angle that has cosine value A, so that's this distance, and sine value B, so that's this distance. If I add 180 to that angle, I'm going to end up over here, but it's going to have some symmetry, right? So this is going to be negative A, and this distance is going to be negative B. So the cosine value will be negative A, and the sine value will be negative B. If I do, the next thing I do 360 minus theta, then that's going to be a fourth quadrant angle that has the exact same x-coordinate, but the y-coordinate will change to negative B. Positive A for the x-coordinate. Okay, on number 28, I want to find the exact coordinates of a point at angle 7 pi over 6 on a circle of radius 2. So the angle 6 pi over 6 would be 180, so 7 pi over 6 is slightly bigger. I can see the radius of that is 2. This is a 30, 60, 90 triangle, so I know the short leg is half of the hypotenuse, so that's 1, so negative 1 because it's going down. And then the longer leg is square root of 3 times the shorter leg. So I have negative 1 times square root of 3 is that longer leg of the hypotenuse, or sorry, of the right triangle. So the coordinates are, the x-coordinate is negative root 3, and the y-coordinate is negative 1.